Hey everyone, it's Justy14 and I would be implementing another project which is called VectorVault. It's basically semantic search in C. What you will further see in this video is demonstration, how the project works, its details and everything. I would recommend you to watch till the end so that you can understand the context of the project and the future scope which can be done. See ya. VectorVault, it is a semantic search implemented in C language. So there are two phases to it. First is Python file and second is the C headers and C files. What I'll be doing is I'll be converting the globe file into a bin file so that I would be able to implement it in C without much of an overall. So I would be concising it to the top 10,000 vectors. So now I'll run this Python file. This is the command Python, the file name, the text file, and where we would be saving it. So we are saving it in data and glove model.bin. So you can download the glove embeddings from this website, NLP from Stanford, and once I do this, it will convert the 50 text into bin. See, I have taken top 10,000 and the size is approx 2.1 MBs. We would be using this command for implementing starting the project. We would first start the EM SDK, which is an external library used to build WebAssembler, the WASM files, and we will go to this particular path and we will do EMC make CMake. We would also need CMake. The external libraries would be listed in readme. Once we do this, it will set up the EM SDK, and now it has set up the build files. Now what we can do is, now this command, the em make command, which uses Ninja, we will do this, and now it will start linking the CXX executable to the HTML file. So what the project scope is right now is use the C files to implement the semantic search, and I'm serving it via WASM. You can also serve it via exe file, which can be downloaded to the PC, but I was running into some errors and I had less time for this, so in a hurry I have made it in WebAssembler format. And now till that happens, I'll show you the sample document. So this is a sample document which explains what is semantic search and glove embeddings and applications. It's a simple document which is used as an index in the code. We can see the linking is done to the HTML file. There are some JS library issues. It's in EM script, and so now this main thing is done. Now I'll run the code. First I'll go to the web, so it would be here, build web and then web. So it has .wasm file, JS, HTML and data file. Now what I'll do, I'll run the Python server on port 8080. So now via Python I'm serving it to the web. So now this is the user interface, semantic search C. I have used AI for UI in C because it was somewhat hassle, but yeah. So now model is loaded here with 10,000 words, as you can see here, and the index is empty. what we can do is we can load the sample here. So I have loaded the sample. The sample is same as this document. It is the same document in samples. So now what I'll do is I have loaded, and now I can query. So on the glove embeddings, the common words are used, of course. So let's say I search text. So now it will give me results. The semantic search concept is used here. So it will firstly divide the index, the document, into multiple chunks. As you can see, it has created 20 chunks for that document. Now in each chunk it would check the query if it's available in that particular chunk via cosine similarity and other mathematical formulas, vector formulas. Cosine similarity is the basis for it, and we can also use other methods, but this project is for understanding that we can use semantic search in C applications. There are 20 results, as you can see, and how word embeddings work, representations of text. So it has given 80.4%, and then it goes down to 50%. Approximately, the approximate calculations are done via vectors, and this is a vector heat map where each dimension is given, and the top result, it is chunk 3, and the heat map, like in dimension 30 it says it is positive, so we have taken chunk 3. So this is how it works. And also you can clear the index, you can clear this, and you can also upload a document here. So let's say I upload a project tech. This is a sample document, and let's say I query assume this, or it would be much simple, so I would say work. So I'll search. So now it will give me chunk wise breakdown for that file also, and we can clear it, so it can be cleared. There's a simple reload thing. So now index is empty. I have loaded a sample. Another feature which I have implemented is to save the index. For example, if I type text again and search, we know it's in chunk 3. Now what I'll do is I'll clear this, I'll clear the index, and now when I do cache index, load cache index, it will load the previous index which I have defined. And now let's say we search again for text, so it would retrieve that results again. Another thing to notice is, as it's based on top 10,000 words, some unique words such as vectors won't be captured, because in glove embedding models the common words are used. That's why we can also add multiple levels of iterations to it. This was my simple project. You can check out my GitHub for this project. I'll public it right now after this video, and I've given how to work upon it. Simple things: cosine similarity, vector space, 2D projection, and yeah, basic. Some potential issues are also listed here, configurations, and yeah, this is the simple code. Thank you.